So let's find the general solution of this. And here we see we have a cos 2x. Okay, we have a cos 2x and we have a cos x. Now in this situation, and we have a constant, so this makes it very difficult to solve this. So what we do need to do is change the form, and what we can do is change the cos 2x, and that becomes 2 cos square x minus 1. Now the reason we use this expansion, it's because we want to keep everything in cos, because we see that we have a cos x here, so keeping everything in cos should make it a lot easier. So let's have 2 cos squared x minus 1 minus 7 cos x minus 3 is equal to 0. Let's just simplify this. We have 2 cos squared x minus 7 cos x minus 4 is equal to 0. Now we can see this is a trinomial. And I know a lot of people get confused with trig trinomials to factorize them. But you just look at this as a normal sort of quadratic equation where your a value is 2, your b value is minus 7, and your c value is minus 4. And if you had to do that with a normal quadratic equation, how you would get it? You would get 2x plus 1, and you'll get 2, we'll get 1, you'll just get x minus 4 equals to 0. Now I left those spaces there on purpose because this is how it would look if it was a normal quadratic equation. Now you just add cos and cos. Okay, and this now we just like a normal quadratic equation, we let one bracket equal to 0. So 2 cos x plus 1 equals to 0, or cos x minus 4 equals to 0. And here we would solve this and say cos x is equal to negative half, or cos x is equal to 4. So on this left-hand side, what we will do is we will find a reference angle. Okay, we will find a reference angle. And we know that, so basically a reference angle, we're going to find the inverse of cos. So if you, on your calculator, you're going to type shift cos, and you're going to enter the positive version of this. So you're going to enter half. And when you enter half, you should get 60 degrees. Okay, and then now we look where cos is negative. Now on our cos diagram, we know that cos is negative in the fourth quadrant, and it's positive in the fourth quadrant, but cos is negative in the second and third quadrant. So we know that the reduction formulae is as such. So we'll say x is equal to, in the second quadrant, 180 minus 60 plus k dot 360, and you're going to get 120 plus k dot 360. Yeah, don't forget your k is the element of integers here. K is the element of integers here. And that's in the second quadrant. And we're also going to know that cos is also negative in the third quadrant. In the third quadrant, it's 180 plus. So we're going to say x is equal to 180 plus 60 plus k dot 360. K is the element of integers. Okay, and then that'll be equal to 240 plus k dot 360, where k is an element of integers as well. And here, well, you can try, but you're not going to get any solution here, right? This is a no solution. Your calculator will show you that there's no solution. Also, if we know our trig functions, this is cos x, and cos x has a maximum value of 1 and a minimum value of -1. It doesn't go below unless this changes, but cos x, the maximum will always be 1 and the minimum will always be -1, so there's no solution there. If you have any questions, please leave them in the comments.